Hi, I'm Anne. I am an application developer for a company called Detroit Labs. It's a mobile services shop. You'll never guess where it's located. I'm currently working on contract with Ford and their automated vehicle space. I started working in Swift almost immediately when Swift came out, and I haven't really looked back since. And I'm always interested in digging into the fun corners and interesting bits. So why did I want to talk about promises today? Interesting story. A couple months ago, a friend of mine was doing a technical interview for a JavaScript position and wanted me to sort of take a look at his code for the little homework challenge that they had him do. And he did something that I thought was pretty nifty with a chain of networking calls using promises. And I had been vaguely familiar with the idea of promises in JavaScript, as in I knew that there was a thing called promises. But I didn't know much more about that. And in that weird serendipitous way the universe works sometimes, Swift Weekly or one of those other newsletters had an article about a new-ish promises CocoaPod from Google. So I decided that this was a sign to dig in and learn a thing. And I always like to dig into the history of something to sort of find out where things are coming from. So I hopped over to Wikipedia. And it turns out that the term promise to describe a proxy for an unknown result was first proposed in a paper by Daniel Friedman and David Weiss in 1976, which means promises are older than me. And not a lot of things are. The idea was expanded upon in another paper in '77 by Peter Hibbard, although he called it an eventual. The terms promise and future get used interchangeably a lot, but they actually mean different things. Someone at the pre-conference party actually asked me about this, so Diego, this is the moment. Generally, a future is a read-only placeholder, while the promise is the writable, single assignment container that sets the value of that future. Another way to think of it is that the promise is the API containing the information on how to resolve or reject the future. Futures and promise constructs were first implemented in multi-Lisp and Act 1, but the coolest feature of promises, the ability to pipeline or chain them together, was invented by Barbara Liskov of Liskov's substitution principle fame, my favorite of the solid principles, and Liuba Shrira in 1988. Although in that case, their implementation wasn't first class in the language that they were working in, and that's okay because that same year the language they were working in, Argus, ceased development. Promises didn't get much love for the next decade or so, but around the turn of the century, there was a major revival in interest in the construct as web development and this request-response model of messaging took off. And now, most mainstream languages either have native support of some kind of promise-like business or have frameworks that add that support in. So what is a promise and why would I want one? In a very small nutshell, promises are a way to stop caring about when your asynchronous task finishes and lets you carry on as though it already has. It's a representation of either the eventual result of that async task or the error that you're going to get if your task fails, or how you're going to handle it. It's also a way to link together asynchronous tasks in a single chain. And this last bit, chaining asynchronous tasks, was the part that really interested me. Asynchronous code, especially networking calls, can get to be a real tangled mess in a production app. And it's also, I have found, the area of the app that tends to be the hardest for onboarding new developers into a project for them to wrap their heads around. And even for developers who originally did the work and then sort of wandered off to work on all of the other features. So I'm one of those people that learns by doing. So the first thing I did was I went ahead and made an app to check out what PROMISEKIT could do for me. And I chose PROMISEKIT specifically because it had been around the longest, it's one of the longest, oldest, I guess, Swift promise implementations. And I figured having all of this history and documentation would be really helpful to me. Interesting point, that got me in trouble later, and I will explain about that in a few minutes. So I hit up the REST countries API to get a list of all the countries in the world, and I put them in a simple table view with some population information and an image of their flag. And then I found the weather API and a currency exchange API to play with. And the idea was I would have this details view where I would show the weather, current weather in the capital city, and the current exchange rate for each country's monetary unit in American dollars. Someday I'll put a map in that little empty part, but I haven't gotten to that yet. In the first table view, I started by just doing a regular vanilla implementation where I reach out to the REST country's API. Everything sort of works as expected. You get your URL request and your session, you start a task. I used Codable, so populating my data models was super great. I like to keep all of my networking business in all together and out of the view controllers, so I use this pattern of creating a networking class that holds all the actual calls. And then over in the COUNTRYLIST view controller again, things are still pretty simple and straightforward. Get the stuff, switch threads, update the UI. Hooray. Things got a little more complicated in that selected view controller where I had all of the country details. Over there, I needed to make 3 different API calls. One to the currency API, one to the weather API, and then another call to a different endpoint of the weather API to get that nifty little icon that tells you that it was cloudy in Berlin a couple days ago when I updated my slides. And there's nothing surprising about how all of these fetch calls work. You build a URL request with the relevant information, get the response, and then send it over to be decoded. Side trip about why you should go to conferences. The relevant part of the currency API response looks like this one when you're converting to the Botswanan pula, and this one in the middle one is the Danish krone, and the one on the end, the Polish zloty. And you will notice that all of these keys are different. And I wanted to decode all of that into one simple currency struct that looked like that, which with coding keys and a consistent key would have been the easiest thing, but that key changes depending on which currency is being converted. Luckily, I was at a conference in the States called CodeMash last year. A woman named Priya Rajagopal did a talk on all the cool things Codable can do, and she taught us how to create containers to map unknown or varying keys into your static struct variables. And I literally remember sitting in that part of the presentation thinking to myself, what kind of clown shoe operation cannot get their keys together in JSON? And then a week later, I was sitting at my desk going oh, well, crap, good thing they videoed that talk. So, go to conferences, learn things. Back to the topic at hand. In my selected country view controller, the network calls themselves were vanilla and not too exciting once we handled the keys issue. But actually kicking off the request for that data and then updating the UI with that information got a little interesting. So fun thing, the weather API I was using sends a code for the weather conditions icon. Actually, they send you an array of weather conditions, and I'm just grabbing the first one because that was a yak I did not feel like shaving at the moment. You can then pass that code into a different URL to a different endpoint to get the image back. Okay, so 3 total network calls, one of which depends on the result of the other. And what happens if one of those calls takes a long time? Like a really long time. Some kind of loading indicator or something to let the user know that they're waiting for some information would be great, but when do you kick it off? And when do you cancel it? Do you nest one of those calls inside the other call, even though they're not really related to each other, just so that you can have a solid stop point for a loading indicator? That felt really gross. Do you have 2 separate loading indicators for your 2 separate calls? That feels real gross. So this is the problem that I was trying to solve with promises. How do I have a series of network calls, a series of network requests in a way that is elegant, concise, friendly to the user while they wait for the information to load, and friendly to me when I come back to this app in 6 months to finally put that map in there or something? If we pretend that this isn't a random, let's play with APIs for the fun of it hack day app, but an actual production product that makes money and is supported by a team of devs, how can I do this so the people that have never been inside my head can quickly grok the code and start building off of it? I started easy with those original fetch all countries calls. When it was your everyday vanilla networking business, it took a handler that took an array of countries. I was passing in another function, and that function would need an array of country objects. PROMISEKIT's pattern, and this is common for the entire promise sort of theory, returns a promise object of the type array of countries. This idea of returning a promise instead of a more familiar data type took a few minutes for me to wrap my head around. So what do you do with this promise, and how do I go from a promise to this like tidy table view of countries? What does it mean to return a promise, and what do you do with it? Well, you fulfill it or you reject it. Fulfill is the success state, reject is the failure. Fulfill takes a thing of the type that you specified in your return value. Reject takes an error. If we've got data, we decode it into an array of countries, and if we have an error, we reject it with the error type. And here's where I ran into my first little snarl with PROMISEKIT, in particular, because, surprise, PROMISEKIT 6.0 included a major change in the promise initializer. In fact, the semantic versioning for PROMISEKIT goes from PROMISEKIT 4 to PROMISEKIT 6. I don't know if 5 ever got released or if they just junked it entirely. There's some reasons involving how Swift handles errors and closures. There's a write-up on the PROMISEKIT site if you're interested in that. It also includes some criticism of Swift, which I thought was really interesting. You can read up on that on your leisure, and I can post a link if you want. So that's what it looks like to, where'd it go? Sorry. So that's what it looks like to return a promise. This is the change that they made from fulfill reject to seal in. There are notes on this in the PROMISEKIT documentation, but they're kind of buried, and when every Stack Overflow answer going back 5 years and all of the tutorials and all of that have fulfill in, I would have made the big change a little more visible than they did, but I could just be still mad because of how much time I spent digging into that. So that's what it looks like to return a promise with one network call, decoding one set of data into one model. And what does this give us over on the view controller side of things? And over here in the view controller is where I really started to see the fun, the promise, if you will, of promises. So what are we doing here? Well, firstly, we're fetching all the countries. When that's done, we are setting the country array to what we get back and reloading the table view with the new array data. We catch the error and handle it in whatever way makes sense. And already, in this simple example, this is addressing something that I have always found super annoying about networking code. And we're going to take a moment because we are among friends here. We're all iOS developers. In this moment, we can speak truth to one another in safety. That's what conferences like this are for. So let us now, in this moment, if only to each other, admit this one truth that we always carry around like a little stone in our hearts. Handler is garbage. You know what I mean. Maybe you call it completion or something like that. It's the generic meaningless parameter name for the closure method that you are passing into an asynchronous call. I mean, look at this. What is this? Is this clean code? One of the fundamental principles of clean code is that names are expressive and descriptive. What's descriptive about handler? It tells you nothing. But that's good because that means it's flexible. But that's bad because what does it ever mean? And all this tells, at least this tells you that whatever handler is handling involves an array of countries. Sometimes you don't even get a type. Many times, you don't even get a type. If you don't know what calls this method, and then you don't know what it's doing, and you have to go up another level, sometimes more than one, to see what's going on. Have you ever had this situation where you have to pass a handler through another function to get it to where it needs to be, like take the handler from A to C by going through B? We all want to pretend that we don't write code like this, but this is the circle of sharing. We're being honest now. We can admit that we have coded ourselves into this corner sometimes. And when the zoo calls to say that there's a bug in production and the ducks aren't quacking, this sort of thing becomes a nightmare to dig through. And another thing, we have 2 entire not safe for work websites dedicated to figuring out how to make this mess in the first place. Nothing about its syntax is intuitive, and I don't know a single person who can consistently put that little @ escaping in before Xcode yells at them about it. Thank you for sharing this moment of honesty. I've never been applauded for one of my ridiculous rants before. You guys should encourage this kind of thing. But promises solve this. Check this out. This syntax is way friendlier, way more readable. First, we do a thing. When that thing is done, update the UI without, take a note, having to manually handle which thread we're on. And if there's an error, we deal with it. This is clear. I can read this code 3 months from now or give it to another developer and be pretty confident that they can figure out exactly what it's doing and why. But that was easy mode, right? That was just one call coming back. One call with a single response. What about that selected country view controller I had, where that turns out is where promises are even more helpful? It's straightforward enough to follow the pattern from my fetch countries to get all of these to return a promise of the relevant type, exchange rate or weather or whatever. And then I can implement it like this. There's a lot going on here, so I'm going to break it down a little. When is a nifty thing that PROMISEKIT has, and most promise libraries have something very similar, that takes an array of promises to be fulfilled, in this case, the promise of an exchange rate and some weather, and then proceeds only when both of them have been fulfilled. The done block occurs after the first two have been fulfilled, after we already have the information we need from the weather response to go out and get the relevant icon image. If there's an error, it gets caught and dealt with. And then finally, this finally block is where I can put all of the UI work that we, once we have all of our data, including an activity indicator, because that when block is only called when all its promises are fulfilled. I can kick off an activity indicator at the start of all of this mess and know that it will only end when all of this is finished. It's useful to the user, showing that a network call is in progress and we're thinking we'll get back to you soon. And then updating the UI all at once and not in like weird little popping in and out pieces. Put it all together, and I think you've got something here that is readable, explicit, discrete. I feel like I can come back to this code later or read this code in a whole new code base and have a pretty good idea of what's going on. There's just one little hiccup. I don't know if you saw it. This guy, this nested promise, tucked into the done block of that big chunk of code I just showed you. There's supposed to be a better way to do this. PROMISEKIT has another block called then that should work per such. When all of these promises are fulfilled, then do this next thing. When that's done, catch the error and finally update the UI. And when I tried to do this, I got this. Despite the fact that this firstly, then done, catch, finally construction is used all over PROMISEKIT's documentation, even when I burned it all down and tried to rewrite it 5 times, I kept getting this error. And through some commentary on a GitHub issue in the PROMISEKIT repo, the maintainer suggests that you just do what I did, which is put everything in that done block, put that extra call in the done block. So I did that because it worked, but I don't like it. It didn't feel promisey, if that makes sense. This sort of nesting things together seems like exactly what PROMISEKIT was supposed to help us avoid. And I workshopped this talk at Motor City Cocoa Heads a couple months ago, and one of the attendees told me that they ran into the exact same thing using promises in their production app, and they solved it by adding an explicit return type, I think is what he said. But when I asked him, I sort of poked him a little bit, how did you know to do that? What was it that got you there? He said that they had struggled with it for a couple of days and finally just started doing that thing where you throw random code at the wall and see what works. And that's what they found, and it stuck. Apparently, it's not documented anywhere, and that pattern I showed before that gets the ambiguous reference error is all over their documentation. Or at least it was a couple months ago. So part of what I was going for in this whole experiment with promises was to try and think about asynchronous code in a new way. The approach you take to solving the problems you have sort of depends on what kind of tools you use. And the cliche version of this is like the golden hammer. If you have a hammer, everything looks like a nail. But really, we do think of different solutions when we have different tools. Our Swift code isn't a one-to-one translation of our old Objective-C code, right? We use protocols and structs and all the things that Swift gives us to solve our promises in a different Swifty kind of way. Nesting that promise in there felt gross, and it kind of affected how I felt about PROMISEKIT as a framework. This was a really simple example that I used with a straightforward use case. When you dig into the framework a little, you can see that it does offer a bunch of other fun stuff that I didn't get a chance to use here that I want to tell you about. There's a race function that takes an array of promises and returns whichever is the first one to resolve. So if you just need the first thing that returns from a chain of calls, race is your guy. Let's say for some reason you want to wait a short amount of time before you do something. You can add a delay to the chain as well. I thought this was really cool. You can combine a race with a delay to create a timeout situation. You set up a race between the fulfillment of the promise and a delay, and if the delay hits first, it resolves the promise. There's some other fun stuff to be found in there, guarantees that can't fail, an ensure block that happens whether a promise resolves or fails. So, this isn't a talk about how PROMISEKIT is going to solve all your problems, clear your skin, water your crops. I'm pretty suspicious of anything that claims to be the one-stop solution for all of your problems. But it is a tool, and it's always great to have another wrench in the toolbox. So let's be real about the limitations and advantages, at least as far as I saw them. On the one hand, if you're doing something simple and straightforward, the adjustment of looking to an unexpected pattern might override the gains in readability. Handler is annoying nonsense, but it's our annoying nonsense, and we know it. But if you do have more complicated business or are handling a lot of concurrent things, I think the readability gains might very much help. I'm thinking of larger projects and code bases that are onboarding new developers into a project already in process, or coming back to an area you haven't looked at in a while. At least in my experience, networking tends to be the first thing you do early in a project. And then once it works, everybody backs away and doesn't look at it too closely until they absolutely have to. So when you do have a bug, you're coming back into some unfamiliar code sometimes. And like I said, promises aren't a new idea exactly, nor is the problem of having to get an API response, get from an API response to a UI representation. But we do tend to settle into patterns and ruts. We get used to certain tools and turn to them more frequently. And I think it's good to shake things up every once in a while and take a look at what else is out there, what new approaches can spark new ideas. PROMISEKIT is okay. It's the one that's been around for a while. It has a ton of documentation and a ton of blog posts. That said, that isn't always entirely up to date or as clear as it could be. It supports Objective-C as well, which could be a win if that's a thing you need to do. It has some issues with Swift's sometimes cryptic handling of errors and closures, and it lacks some features that other frameworks promise frameworks have to offer. To sort of quickly go through what those other options are and what they have to offer, Google has a promises framework that works very similarly to PROMISEKIT with a few differences. It also supports Objective-C, but it's a little lighter weight when you're adding it to a project than PROMISEKIT is. This I thought was kind of cool. Google Promises offers an all state that is slightly different from their when condition. All in Google Promises works like PROMISEKIT's when all of these promises are fulfilled, do some stuff. Whereas in Google Promises, their when is an or condition. When one or more, but not all, of the promises that you fed in there can reject, and the when will still be fulfilled. PROMISEKIT's when fulfilled errors if one of the promises does in there. And it doesn't really have a similar state for wait until everything's resolved either way and then proceed. Bright Futures said something in their documentation about how they wanted to be the Swift standard promises library. We'll get to why that's probably not going to happen in a minute. They seem to offer much the same functionality and a similar enough implementation of things like then to PROMISEKIT, but they also make some interesting use of map and filter in their chaining of promises. Hydra is another large in terms of use, not in terms of binary weight option. And they have some interesting options for handling some or all of your promises failing. In the end, I accomplished my goal. I learned something about promises, and what I learned is that I kind of like them. Would I include a promise framework in my next big client project? Solid maybe, leaning yes. Most of our client apps use APIs that are convoluted enough that I think some promise gains can be made in terms of readability. And it's fun to play with new toys. But I might give one of the other frameworks a try. Oh, wait. You may be saying to yourself in this moment, what about async await? That's coming, right? And that's a great point. There's been a proposal to add async await to the Swift standard library for all of the reasons I mentioned earlier about how callbacks are the worst. The async await proposal would add an async type of function, like the throwing type of functions that we have already. You'd mark a function as async, similar to how you'd mark it a throwing function. And then when that function is called, you'd specify that you are awaiting the result. So now, for example, my various fetching data calls would look like this, where they'd be tagged async. And the call site for these functions would look something like this. You would set these exchange rate weather icon variables to the awaited result of those async calls. And honestly, I think that's just beautiful. Of all the options out there, this is the syntax that I liked best. I thought it was super clear. It passes that test of I can come back in a few months and know what's happening. It pattern matches to the try, catch syntax that we've already got, and having it built into the standard library would be super great. The proposal includes strategies for deferring and abandoning async calls, as well as APIs that will have multiple result arguments beyond, beyond error. Unfortunately, this was originally proposed and rumored to be added to Swift 5, but that didn't happen. There's some bike shedding to be done around the syntax, and I think the focus on ABI stability in Swift 5 kind of crowded out a lot of other things. This proposal's moving forward, and the expectation is that it's going to get in eventually, just when? Probably sooner than later, hopefully. I'm really interested to see what happens to the concept and use of promises in these various promise libraries once async await lands. I think this is going to probably obsolete a lot of the sort of promise stuff that I just talked about. I'm definitely going to be rewriting my entire app in async await once I can get my hands on it to get a feel for it and for how it will change. And hopefully I can come back soon and tell you about that. Thank you for listening to my muses and my random rantings. You can find more of that on Twitter. I am north of normal, just about everywhere you can find a person. And I will put this code is already on GitHub as well, and I will get that map up on that details page one of these days, I promise. Thank you very much. I think there's time for questions. Questions yes, questions no? Questions yes. Okay. If you have questions, go for it. If you don't, we get to ice cream faster, just saying. Let's go.
So a very nice presentation. Thank you for that.
Thank you very much. Thank you. It's kind of good to say.
In our company, we use RX, which has a little bit of the same logic, I guess. Mm-hmm. I didn't see it in your options, but would you say you would consider it for the same things, or is it too wide of a scope to use where you use promises?
I haven't played a whole lot with RX Swift, but again, it seems like a whole nother way of looking at this problem of information coming in and waiting for some sort of result before we do a thing. Yeah, I haven't dug in a whole lot into RX Swift. Is there a need for promises there, or does the reactive nature of it?
Yeah, because I see it as very similar. Mm-hmm. So, but it's a little bit more overhead, I guess, a little bit more complex to learn. But I think most things you do with promises, you can do with RX Swift as well. So,
my experience with it is, like I said, it's limited, but it seems like it's a whole lot to bring in for maybe something that could be handled with async await someday, or a lighter weight promise I don't have to rethink how I'm doing every single thing.
Right.
I just have to sort of tinker with this one part of it.
Okay,
Cool.
thank you.
Thank you. Questions? Got another one over here.
What do you think about NS operation with operation queuing compared with promises and chaining?
My experience is that there's a whole lot more fiddling with things with NS operation queue. Most of the promise libraries handle and abstract a lot of the window blind fiddling that you have to do manually with setting up an operation queue. So I find them a little bit easier. I know some people really enjoy having their hands on, like, I'm going to handle the operation, and it's going to be all me, and I'm going to be a control freak about it, and that's great. I'm a control freak about other things, and tend to defer and wrap most of my networking code in something that's a little easier to handle, or a little easier on my cognitive load, I should say. Any more questions? No more questions? Awesome. You guys have been a fantastic crowd, and it has been a huge honor to speak here today. Thank you so much.